So before we get going with our new topic for today, there were a lot of questions about how to find a specific amount of profit when we're looking at a graph of a cost equation and an income equation. So let's just look at the example that we did the other day. So we had two lines. We had our line for cost, which was $1,500 plus 10x. So I have to pay $1,500 to rent this center plus $10 for every person. So that's my line for cost. At the same time, I have a line for income. Each person that comes pays $16. So this is my line for income. So at any point on the line, we can find take the number of tickets, and we can use that to calculate how much money we've spent and how much money we've brought in. So say, for example, at 100 tickets, the value of the income line was $1,600, and the value of the cost line was $2,500. So at that point, if you had 100 people attend your event, you would have spent $2,500, but only made $1,600. So the difference there is $900. And in that case, that's a loss because that's money that you've paid and you didn't get back. As we move closer to the break-even point, which was 250 tickets and $4,000, that gap narrows. So at this point, if you had exactly 250 people attend your event, you would break even, meaning the amount of money you spent and the amount of money you earned would be exactly equivalent. So you wouldn't be out money, but you also wouldn't gain any money. After that point, the line for income is higher than the line for cost, which means that for any given number of people that attend, the amount of money you bring in is greater than the amount of money you spend. So for example, at 300 people, the amount of money you would have spent would be $4,500. So that's the Y value when X is 300. On the other line, the income line, the Y value for 300 people would be 4,800. So same X value, but different Y values. So at this point, you would have gained $4,800, but only spent $4,500. So that means that you would have made a profit at that point of $300 because that's the difference now in the positive between what you bring in and what you have spent. So if we're looking for a specific amount of profit, we want to find the place where the difference between those two lines is going to be $1,000. So using the graph, we need to look higher and find the place where that distance between the income and the cost is going to be $1,000. Okay, so here's my graph. I've got my line for income and my line for cost. And we already said that at 300 tickets, the difference here was only $400. So I'm going to need to go a little bit higher. Let's take a look at 400. Let's just zoom in a little bit here. So at 400 people attending or 400 tickets sold, I would have spent $5,500, but I would have made $6,400. So the difference at that point is $900. So I'm getting close. So let's go up a little bit farther to, let's say, 420. So at 420 tickets, I would have spent $5,700 and I would have made about $6,720. So right there, I've made $1,020. So my number of tickets is going to be pretty close to 420. And actually, if we kept trying and guessing and checking, we would come up with 417 tickets because that's where it gets closest to $1,000 of difference between this line, how much you've spent, and this line, how much you earned. So today we're going to look at solving equations by substitution. So think for a minute about the goal we have when we solve equations by graphing. The goal is to find the point where the lines cross, because that's the point that's going to be the solution to the system, because that x value and y value makes both of those equations true. What that also means is at that point, the y value of the first equation is the same as the y value of the second equation. So at that point, y equals y. What that also means, though, is that if I take the other side of the equation, those would also be equivalent. So x would be equivalent to 2x minus 2. So now I have an equation with one variable that I can solve. X equals 2x minus 2. So I can subtract 2x from both sides. So negative x equals negative 2, which means x must equal 2. So the x value for the solution to the system is 2, which matches what we see on the graph there. That also means then that I can use these equations to find the value of y. So if y equals x, well then y must also equal 2. But it also works if I plug x into this equation, because 2 times 2 minus 2 does in fact equal 2. So this can be useful, especially when we have two equations that are both in slope-intercept form. So if I want to find the solution to this system without graphing, I know I'm looking for the point where the y and x values to both of those equations are the same. So at that point, the y value of the first equation will be the same as the y value of the second equation. This y value is equal to 2x minus 5. So that's going to be equal to 3x minus 1. So at that point, if I plug x into this equation and x into that equation, I will get the same value of y, which means they must be equivalent at that point. So now that I have an equation with one variable, it's something I can solve. And remember, we always do the same thing to both sides. We have to be very careful of our negatives here. So here, I get x equals negative 4. So the next step then, once I have the value of x, is to find the value of y using one of these equations, and then check my solution by making sure I get the same value of y for the second equation. So let's take the first one here. Y equals 2x minus 5. And we think x is negative 4. So y would equal 2 times negative 4 minus 5. That's negative 8 minus 5. So the value of y would be negative 13. Let's do that with the second equation just to make sure. So if I take this equation, y should equal negative 4 times 3 minus 1. That's negative 12 minus 1, negative 13. So I've found the value of y that matches this value of x, and I've double checked it by plugging it into the second equation. So therefore I know that the point that is on both of those lines is going to be negative 4, negative 13, because it makes both of those equations true. Now let's say we have a situation where we have one equation that's in slope-intercept form and one that is not. So if I want to set y equal to y, I know that this equation, y is equal to 2x plus 4, so I can replace y with 2x plus 4. On the other side, however, I need to do a little bit of rearranging so that this equation is set equal to y, so I can replace the y here with the expression with x. So if I want to solve this equation for y, I would need to subtract x from both sides. So y equals 10 minus x. So now that I've rearranged it to be y equals, so in slope-intercept form, then I can plug that into this side of the equation. So now I have an equation in one variable that I can solve, because I know that at the point where those lines cross, 2x plus 4 has to be equal to 10 minus x. So I'm going to add x to both sides. And then subtract 4. And then divide by 3. x equals 2. So based on my solving of this equation, the x value of the solution is going to be 2. Let's take this easy one here to calculate the value of y. If x plus y has to equal 10 and x is 2, then y should equal 8. Just to double check, I'm going to take that value of x, put it in this equation, and make sure I also get 8. So y should equal 2x plus 4, 2 times 2 plus 4 equals 8. So you use one equation to find the value of y, and then use the second equation to double check and make sure you get the same y value. And that proves that the point that makes both of those equations true would be x equals 2, y equals 8. And finally, sometimes we have a situation where we have one equation in slope-intercept form, another that is not, but it's going to be multiple steps to try to rearrange this into slope-intercept form. So a more efficient method might be to substitute this y value for this y value to give ourselves an equation with one variable. So remember that we are looking at the point where the x and y values are the same, which means that at that point, this value of y is the same as that value of y. So if I replace y with something it's equivalent to, because this y is equal to that y, and that y is equal to 1/2 x minus 1, now I have an equation in one variable. So this works for systems again, because at this point in time, this value is equal to that value, and this is equal to this, so I can just replace the y in this equation with 1/2 x minus 1. And now I have an equation in one variable that I can solve. So first I need to distribute. Remember to be careful with our signs. Minus minus makes plus. This is why it's important to always check your solutions, because it's easy to make a mistake here with the integers or with solving. So based on my solving of that equation, the value of x for the solution is 4. So let's take this value, or this equation here, and use the x4 to solve for y. So y should equal 1/2 of 4 minus 1, which is equal to 1. So I think x equals 4 and y equals 1 for this system. What I'm going to do now is use this first equation to check that my values of x and y both work. So 4 times 4 minus 2 times 1 should equal 14. 16 minus 2 does equal 14, so I know that I'm correct with that solution. So the types of questions you're going to see in the practice set will fall into one of those 3 categories. So one type will be where the equations are already in slope-intercept form, so you just have to set them equal to each other. Some of them will be a situation where we have one that's not in slope-intercept form, but it's easy to rearrange it and then set them equal to each other. And some will be the type where we need to replace one of the variables in one of the equations with something that's equivalent to get an equation with one variable.